Alright, I think this will be the last of our videos on lesson 11.1. We just left off on this idea of alternate exterior angles, and those types of angles are on the outside of the parallel lines and on opposite sides of transversal. So angle 2 and angle 7, angle 2 and angle 7 would be a pair of angles that would qualify as alternate exterior. And the interesting thing about alternate exterior angles is that they are indeed congruent. They have the same angle measure when they are in those positions. So they are congruent. And if we have alternate exterior, well, you can guess that we also have alternate interior angles. And alternate interior angles, instead of being on the outside of the parallel lines, they're on the inside of the parallel lines, but they still are on opposite sides of the transversal. So opposite sides of the transversal. I'll get a different color here. I'll go with green. So angle 3 and angle 6 would be good examples of alternate interior. Angle 3 and angle 6. And guess what? Just like the alternate exterior, the alternate interior are also congruent. So let's just recap all of this. Let's just draw a new diagram here. I'm going to draw a set of parallel lines. I'll draw a set of parallel lines with the transversal. And I'm going to go in and number all of those angles. So I'll put a 1 and a 2 and a 3 and a 4 and a 5, 6, 7, 8. And for good measure, I should go ahead and put those arrowheads in here on my line. So there's these guys here are my parallel lines. So I could call this angle A, line A and line B. So I could say that line A is parallel with line B. Oh dear. So if I tell you that the measure of angle 1 is equal to, well, let's just say 120 degrees, guess what? You could tell me the measurement of all of the other angles just based on that one piece of information. And it has to do with everything we've just learned. So it's true that vertical angles are congruent. So if angle 1 is 120, so is angle 4. So I could put that down here that the measure, so that the measure of angle 4 must also be 120 degrees. And then I also know that angle 1, this guy right here, and angle 8, well, those guys are alternate exterior, so that means that they are congruent. So then that must mean that the measure of angle 8 must also equal 120 degrees. Well, that's fantastic. And then from angle 8, we know something else. We know that angle 5 and angle 8, well, those guys are vertical. So what must that tell me? That means that the measure of angle 5 must also be 120 degrees. And not only can we look at that from the perspective of 5 and 8, but we also know that, here, let me get rid of this little thing here and this little thing here. We also know that angle 1 and angle 5, those are called corresponding. And so corresponding angles are also congruent. So if this is true, all of these guys are equal to 120, then what about the ones that we haven't highlighted yet? Well, we can use our other knowledge. We know that angle 1 and angle 2, these guys together are creating a straight line. So angle 1 and angle 2 are supplementary. So the measure of angle 1 plus the measure of angle 2, well, that has to equal 180 degrees. That's what makes them supplementary. So we have 120 degrees plus the measure of angle 2 is equal to 180 degrees. So we can just subtract and we can figure out that the measure of angle 2 is equal to 60 degrees. And then using the same type of reasoning that we did with everything else, if angle 2 is equal to 60, well, then the measure of angle 3 must also be 60 degrees, and that's because they're vertical angles, and vertical angles are congruent. Okay, so then what about 6? Well, that means that the measure of angle 6 must also be 60 degrees. And the argument I can make there is that 3 and 6, so angle 3 and angle 6, they're alternate interior angles. And we know that alternate interior angles are congruent. And then lastly, we can say that the measure of angle 7 must also be 60 degrees, and we could use the vertical angle argument there. Vertical angles are congruent, and 6 and 7 are vertical angles.